America and currently serves as the Associate Secretary and is an editor of the MAA Instructional Practices Guide. Most recently, she received the MAA Deborah and Franklin Tepper Hymo Award for Distinguished College or University Teaching of Mathematics. And Hortensia, we're so happy that you're here with us this evening, and you've spent so much of your day with us today on the equity panel and the roundtables that we just had, and we're really thankful for that and excited to have you here.
Thank you, Brianna. I'm very excited to be here. And I want to thank everybody for showing up. I know it's later in the day, and I'm really excited to see how this is going to turn out. It's the first time I've been doing anything like this virtually. I do activities like what we're going to try to do tonight all the time in my classes, but I thought, well, if I do this, I want to do something different. So I really am grateful that Brianna was open to my suggestion of what the workshop will look like. So I'm going to go ahead and share my screen. And I just have a small PowerPoint, and then we will get to acting out the mathematics. So my workshop is entitled Acting Out Mathematics, and in the background you can see some of the work that I've done. This is with collegiate teachers, but this is work that I've done with my undergraduates also, and this is transformations on the plane. So I have that giant tarp that I created that acts as the Cartesian grid, and students act as points on that grid. So let me start with a short story to give you a sense of what embodied cognition is. So this is in a course for my pre-service elementary teachers. It's a geometry course. And we're getting ready to talk about Euclidean transformations. And as usual, I always ask my students how they think about a concept before I introduce it formally. And so we were going to talk about rotations. And I said, so how do all of you think about rotations? And Timmy in the front row raises his hand. And I said, okay, Timmy, how do you think about it? And he said, well, it's like, and if you're not looking at the screen, please do so, and I'll say it again. He said, it's like, I don't know. And so my students know that I pay attention to gesture. And so I said, okay, Timmy, I'm going to revoice and regesture what you just did. You said, it's like, and he goes, oh, it's like a turn. That's really the idea behind embodied cognition, is that learning is body-based. And so Spencer, if you don't mind switching slides. So embodied cognition is a philosophy that learning is body-based, and really that our body knows something and can enact something before we're able to articulate it. And if you think about a child when they're first trying to communicate with us, and they want a glass of water, they might point to the faucet to indicate that they want water. And later on in life, they'll be able to use the word wah-wah for water or water. And then much later, they can begin to actually write out the word water. And this is the idea that I adopt in teaching mathematics, that I believe that my students can convey ideas to me first via gestures before they can convey it either verbally or in writing. And here's a nice quote by Skemp that I like that kind of illustrates what it is that I'm trying to say. And so I'm ready for the next slide, Spencer. So embodied cognition is a way for us to pay attention to our students' body language, eye gesture, facial expressions, gestures that they might make, entire body movements, that helps us to figure out what it is that they already know, the knowledge that they're trying to construct, the knowledge that they're trying to convey, or the concepts that they might be grappling with and are almost on the verge of really embodying that or connecting and being able to convey in words what they're what they're thinking, what their body is doing. I'm ready for the next one. So we're going to act out some mathematics today. And I know that we don't have as many participants as that I had originally thought. So the rules are going to change a little bit, but the idea is going to stay the same. So if I can go to the next slide, I'm going to go through the rules. Ooh, let's see if I can even read these. But here's the idea. So all of you are going to go to a table, and I would like the tables to have 3 to 4 participants. And we're going to have A tables and we're going to have B tables. So we're going to have like A1, A2, I'm sorry, A1, B1, A2, gosh, can I say this correctly? 1A, 1B, 2A, 2B, 3A, 3B, and so forth. And at each one of those tables, I would like for you to get in groups of 3 to 4. And then each table is going to get a geometry-related statement, fact, or theorem. And there's going to be like 4 statements that each of you will get. And then the table B, the B tables will get different statements, but also geometry-related statements, facts, or theorems. And then at each table, the group will choose one of those statements. And as a group, you will decide how you would enact what that statement or theorem is saying. And you'll have about 15 minutes to create that enactment as a group. You'll decide who's going to do what and when and so forth. And you don't have to do all 4. I don't anticipate you're going to have time for all 4. But if you have time to do a second one, then go ahead and work on a second one. And then after about 20 minutes, everybody who's, for example, in the B2 will go to A2. Anybody who's in B1 will go to A1 and so forth. So we'll conglomerate into the corresponding A tables. And then what we'll do without words, and here's the important part, without words, the A table will gesture, body movement, whatever, display the idea that the statement that they're trying to convey only using gestures or body movements, but no words whatsoever. And the B group will try to guess what they're saying. And we'll give you about 15 minutes to do that, and then we'll switch. And of course, if you finish before that, feel free to switch and have the B group do their gestures.
I kind of love this idea. I have a child who is nearly nonverbal on the autism spectrum, so I am all over this.
This is awesome. Yeah.
Live in the nonverbal world.
Really good.
I like 3 and 4. I think either of them would be easier than 1 and 2 would be really hard.
Fire?
Yeah, I think they would.
So I teach vertical angles with a bow tie. Does anybody have a bow tie?
No, but that's a cool way to do that.
What's in my classroom? It's not here. It's the only one I have.
So are we thinking, which one are we thinking of doing?
I think just 3 or 4. I think 3 or 4 would be the easiest. 1 and 2 would be really hard. Because 1 requires a number, so what do you do if you're not allowed to talk? How do you say 360? So, yeah. So you have, I guess it depends on what assumption we're making of what's the level of our student.
Exactly,
right?
Julie.
Yeah.
If a student knows that if it's common knowledge, for example, if they've had some basic pre-algebra geometry, they'll know 360. But do we know what the assumption is? Who's our audience? Is it elementary, middle?
It's table 1A. Oh, I don't know. We're just presenting to them. So.
But are they taking a role of being a certain grade or age?
I don't think she said.
Does it say it on the paper?
No.
Mm-mm.
Is it possible to hold up a piece of paper and do it? Like if we had 4 right angles?
No, because it says with just gestures and body, it says no words. And so writing is also words.
You have to make it.
I would assume that our audience is like 9th or 10th graders that are taking geometry.
Okay.
Like that, maybe? I don't know.
I'm trying, yeah. Triangle. Yeah, you could have to flip it over or draw it,
I was thinking for number 1, I was thinking, just that plus that. And you'd see.
You can do plus, you know.
I guess 2 would be okay because you could talk about when they intersect that they're congruent, but
Or Tabitha's got some props over there.
yeah.
Yeah.
I guess one benefit of doing this is multimodality. So when we reach out to our students, if somebody is even a student who kind of gets it, if they're dozing off at that point, just one more way of getting their interest.
Yeah.
One more sense.
Yeah.
Yeah.
Yeah. What would you do for all squares or rectangles?
I would say something like this.
Mm-hmm.
Well, that's very ambiguous, right? So all squares. Well, what I would do is I would say, and then, yeah, 4 would be hard actually.
Because our fingers are not the same lengths. That's
right. Yeah, you'd have to. Yeah.
I can just point to my head, say I'm a square.
Tabitha's working on something very interesting.
Oh yeah. Can we use paper and other? I thought it was just our hands or something.
Yeah, it just gestures and body. We'd use our bodies.
Yes, we can't really use paper.
In her picture, it had them with a triangle that they made out of string.
Right.
So we could tell them to go get 2 straight sticks of any type. Or I don't guess we're telling them how to act it out. It's not charades.
What if we had a rubber band? Can we use things like that? Because if you have a rubber band, you try to stretch it to be a square, and then stretch it a little bit more.
I think we're basically trying to play charades.
Mm-hmm.
You think what?
You know, and you can't talk and you can't use things.
Okay.
Can you repeat that, Julie? You think what?
I think we're basically trying to play charades.
Oh, I think so too.
Okay. Yeah.
And you can't talk. You can't, you know, you just could gesture.
What's a gesture for sounds like?
That's it.
Yeah.
Oh yeah.
One syllable. One syllable. Or it's like this, one syllable.
So which one do we want to do?
Yeah.
I suggest 3 or maybe 2.
Yeah, because with number 2, you can use your arms.
Yeah.
I think 3 sounds hard.
Yeah, there you go, Tabitha. Yeah.
I feel like this.
Yeah. Oh yeah, you can that. Yeah.
I was just thinking you could start with like a right angle,
Mm-hmm.
because then that shows them the 90 degrees.
Mm-hmm.
And then
Oh yeah, with what Julie's doing in conjunction.
yeah. And Julie's like,
I like
hey,
that.
this is a good angle. So
Tessellation.
Yeah.
Rotation.
And we have the extra challenge. We're not in person. We're over, the internet, which adds a little complication. We can't really use our whole body. It's hard to project the whole body.
Yeah, you have to like back.
Right.
Go back far enough.
So it looks like you don't know what direction you're going in.
Oh, props are okay.
Props are okay. Oh,
Oh, now
that's
they
a game changer.
That's a big game changer.
It is. What if we use the rubber band for a square and a rectangle? That would be pretty easy.
That
We just have to find one.
That might make 4 easier. Yeah.
4 would be easy that way. Do you want me to go get one?
But I agree with you that I'm in favor of that one. And while Jessica's not here,
I like that, Jennifer. Yeah, number 3. Well, see, so my question is going back to that triangle, because I think you have that one pretty good. Do we have to, like, does it have to be
So let's do it.
precise? What was that, Sue?
It said props are okay.
Yeah, Jennifer's got one. Oh,
the
she's
paper-
thinking about the triangle now.
Yeah, I never understood the triangle one until I saw that demonstration, and then it was so clear.
Yeah. It does make it clear. I can't see your triangle. Did you draw it or no? Oh, okay. You're just cutting it.
Cutting it.
We'll start with it already cut.
That's not gonna work. But it can work on this side.
I think this is pretty okay. I have these tips from before, and I just go this and this, and that's pretty good.
Yeah, so you got that, and it doesn't matter if
And I
it's
point
deeper.
to here and point to here, and that should be okay.
Yeah. Well, especially if we're both doing that, then it would be pretty clear what we're trying to, right? Because they look a little different, and yet we're still talking about those two sides.
How about this? Can you tell all squares are rectangles when I do this? He's a square, here's a rectangle. All squares are rectangles. You can't jump from here to here, right?
How about if I do this? So I've got this and this, right?
Mm-hmm.
And then I just take this and move it over here to show it's the same. That was very quick.
Yeah, that's nice.
So I make an angle. And it'd be good if we actually had different size angles.
Right. So you got this is the same as this.
Oh yeah, switch hands from one place to the other. Yeah.
Or, you could have, even if it's bigger. Okay, now this is the same as this. So then if we have 3 versions of the same thing going on, maybe that would help.
So how do we do the other one which says all squares? The diagonals of
I thought we only had to do one statement. Do we have to do
We
2?
only have to do one. We can be ambitious.
I'm just thinking about it. So
I'm gonna work on my people.
and we can say equal to this. Yeah. All right.
Yeah, too many things to hang on to for the other one.
Well, I dumped all my pens and I got my box for the pen, which is a rectangle. But then how do we get from here to say all squares are rectangles? Azucena, you are muted. Okay.
I was talking to hubby.
Okay.
Eating.
We made a keto pizza, so we have a cauliflower crust.
Oh, crust. Did you make it from scratch?
First time I made it. Well, I used some spaghetti sauce to cheat.
No, but the cauliflower crust.
So it's here. Let's exchange recipes. It's cauliflower rice mixed with 1 egg and a cup of mozzarella that you bake at 450 first after you kind of spread it out to make a crust for 20 minutes. And then you pull it out and you treat it like a normal pizza crust. So, sorry.
Yeah, you're good.
So the diagonals of a parallelogram bisect. So what kind of props could we use for that if we are not drawing anything?
Yeah. We can use props, but I don't think she really wants us to just take out the piece of paper and draw it.
Oh, yeah. Fold it.
You're muted.
That's why I folded the paper. I didn't even cut it. So.
Yeah, I like yours though, where you just had it. Or
knowledge.
Right. I like it.
For the purposes.
When are we supposed to do this?
Oh, that's neat. I guess as a team we have to enact this. So when we say that, what do you think of this idea? What if we started with a rectangle, not a square, and we hold up the rectangle and say, and then, show the angles, and then say,
well, how about if we showed something like this? Like put a rectangle over it that matches it, take it off, show this.
And then thumbs up, that is also, right? Because we count with the rectangle.
It's the same idea.
There's 4 sides and there's 4 90-degree angles. So we put that down, then we hold this and count and say, yep, this is also what we just saw. Every square is also a rectangle.
Yeah. Either way, they're yeah. Do we all have to agree on one thing though, or just
we have to work as a team, I think.
Oh, okay.
Let me read the document again, but I think we're doing it as a team.
Yeah, we work as a team.
Don't sound very helpful.
Okay. So what are we holding up first? Rectangle or square?
I think we should hold rectangle and define what a rectangle is.
Okay.
And
we're
the
all
definition is
rectangle, and we're going to define it by
4 sides and 4 right angles.
Around it, saying angles, 4 sides. We're going to stop at the angles, kind of.
Yeah, I think we should count. So 1.
What if we did this for rectangle, and then you take off one of them, and it shows, I don't know.
I think what we should do is do the rectangle, then do the square,
and put your thumbs up. It's the same.
Then put them together.
Yeah.
And then yeah.
So on the rectangle, we're trying to emphasize that there's 4 right angles.
Right.
You can do that.
And
yeah.
So we're all kind of drawing that, and okay, then we put up our square.
Then we do the same counting and say it's the same. So say
right angles.
Up.
Say 1, 2, 3, 4, and then we can count these and say 1.
Mm-hmm.
Well, we could do that, and that would work fine. But another approach is we could do it at the same time. So we could highlight the 2 features that make it a rectangle that we're concerned with, and then check those 2 features out and do a thumbs up that they're the same features.
So point to the rectangles and say, yep, 4, thumbs up.
Yeah.
Okay. That's good. So at the beginning, we're emphasizing the rectangle, the right angles.
Yeah.
Mm-hmm.
Then we're saying 4 right angles, yes.
Mm-hmm.
Then we're somehow putting the 2 together.
I love it, Tabitha. That's great.
Oh my God.
You can tell you have been teaching from home and haven't been back to school yet.
Yeah. They both work. Yeah, whatever way you want to do it. Yeah.
Okay. Then we try to express the 2 together. All right, we got it.
So who's going to show it? Julie?
All of it.
Oh, we all do. Oh,
yeah.
We all do the same thing, or do?
So we need to practice. Yes.
Well, the good thing is with variability, we all have different examples, so they'll have the commonality. So we have our own kind of rectangle, our own kind of square. Different. Some are big, some are small. I think that's good.
Okay, countdown from 5. We're getting ready to go. Ready?
Okay.
5, 4, 3, 2, 1.
Who is saying what?
We're not saying anything. Can't talk.
We're not saying anything.
Can't talk.
Well, no. Who is showing?
We're all showing it.
We're doing it together.
Because if they're
all doing this together.
We're synchronizing.
Synchronized.
So you don't think it would be overwhelming?
Well, we'll do the best we can.
We got it?
I think so.
I think so. Am I doing it right? I
think so.
So we're all pointing out four right angles on a rectangle. Then we're shifting to 4 right angles on our square. Then we're showing them together and we're going, yeah, squares are rectangles.
We're doing the corners and the sides on the rectangle, then the corners and sides on the square, correct?
Yeah.
Okay.
Corner, side, rectangle. Yeah. Okay.
We're doing both features of the rectangle, then both features of the square, right?
Mm-hmm.
Right.
Okay. Yeah, that should work. I'll get it.
All right. So let's predict.
I wonder
how much confidence do we have in ourselves? Do you think they're going to get it? I say yes.
I think so.
What do you think?
I think so.
Yeah.
I think so.
Philip?
I think so.
Jeannie?
I think so.
Tabitha? Ooh, we're 5 for 5.
I think we're clear as mud.
We have a lot of confidence in ourselves.
We might have to do it a little slower so they can see what we're doing.
Do you guys ever feel like this? Used to have this on my desk.
Oh, wow.
Oh, yeah. So, do you think we should have like one person saying, like, this is the first idea?
No talking.
Not verbally.
Just, yeah.
Like,
do we have to
pointing
even
out.
know which
Like
one we're
number
doing?
one. Yeah.
We're just doing one. We're just doing that one.
Well, but there's different parts to the idea. There's the 90 degrees. There's the sides.
We're not supposed to talk at all.
Okay, how about this? Since am I on the far left of your screen for the video?
You're all second to right.
Oh, okay. Well,
so we're different for everyone.
One of us, it doesn't matter. It can be me. I'll put it up, and then as soon as I go to a square, everybody else goes to a square.
Okay.
Because I go to double, everybody goes to double.
Okay.
Sound good?
All right.
I didn't follow that because I thought we're all independently showing our rectangle and independently showing our square.
We are, but we want to all go to the square at the same time.
One, 2, 3, 4, 5. Okay. So A goes first.
Oh, really?
That's what it said.
Lucky us.
Okay, so Lisa, do you want to do this with me?
Okay. All right. What should I do with you? What are you going to do?
You just do the first. Yeah, just.
I'll do the first one. Okay. All right. Here we go. Let me look at it again. All right. Here we go. Okay.
Triangle.
Okay.
Right triangle.
Triangle.
Vertices of a triangle.
Triangle?
3 sides to a triangle.
Complementary? I don't know.
60. The sum of the angles of a triangle is 3 times 60 degrees.
You got it.
180 degrees.
You got it.
I'm sorry, what was it? Say
60. Sorry, guys. Well, that's what she was trying to say.
what did she say? What was it?
I said the sum of the angles out of a triangle is 360 because that's where I thought it was 360 there.
Right, but it's 100.
Bad theorem. This is not that. No.
But you were on the right track.
Yes.
So I'd say that you guys got that one. Yay.
Okay.
All right. Somebody else?
Now it's Steve's turn.
Okay. We're going to do our first one?
Yeah.
Sure. Okay. Here we go. Okay. Kelly first.
Okay. Parallelogram.
Mm-hmm.
Yes. Diagonals.
Mm-hmm.
I mean, I know it's true about the diagonals of the parallelogram, but that's kind of cheating. They are, well, they're not always perpendicular, but okay. They might be each other.
Yes. You got it. You got it?
I like the
That was Debbie's idea. Yeah, I just enjoyed it so much that I had to have it.
Okay, A's turn.
I don't know that we have another one. Okay, so I turn. Okay. Can I try?
Yes.
Yes. Okay, so wait, let me see if I can. Okay. Can you see me? Yes?
Mm-hmm.
Yes. Go up higher. There you go.
Triangle?
Yes. Okay. Yes. Okay. This part and this part. Yeah. Okay.
Okay. Base angles of an isosceles triangle
So
are congruent.
yes.
Yes.
Right. Yeah. Same with this triangle.
Mm-hmm.
Yes, that's right. The basis of an isosceles triangle, the angles are congruent.
Mm-hmm.
Okay.
That was good. I liked it.
Wow, theirs are so much easier than ours.
I know.
I think we just made our hard.
Okay. Okay.
All right.
Okay. Second one.
Yes.
Okay.
That one, right? Or
Oh no, I thought our second one was this one.
oh,
Yeah.
got it. Okay.
Yeah.
Okay. Yeah.
Okay.
Yeah. So.
Okay. The circle.
Uh-uh.
Oh, so the square.
Square,
Mm-hmm.
square, oval, or ellipsoid, ellipse. Sorry.
Rectangle. Rectangle.
Yes. Yes.
Every square is a rectangle.
Yes.
Okay.
Oh, I thought we were doing the.
Nice.
Sorry.
Okay, so we have last one, right? Yes.
Okay. All right.
Okay, so I have this one. Okay, here. You got another one.
Okay. Right angle. Right triangle.
Okay. Yes.
Right
Triangle.
Okay.
Pythagoras.
Okay. Hypotenuse.
The
What do you got?
non-right angles of a right triangle.
The hypotenuse.
A squared plus B squared
no,
equals C
the-
squared.
The
The
angle.
angles. So the non-right angles of a right triangle are complementary.
Yeah, correct.
Oh! Very good job. All right.
So funny.
Okay. We want to try our third one.
Okay. Which one is the third one?
The one that yeah, this one.
Okay.
No.
Okay, ready?
Yeah.
Okay.
Ready. Okay.
No.
Oh, vertical angles are congruent.
Got it.
That was really good. I like that one a lot.
Yeah. Good. It's like dancing.
It was great.
Right. I loved it.
Okay, the last one of ours is the one I was talking to my group about at the very end. So I wouldn't want to be the second person. They would remember what I said. It's the last one we haven't done yet. No? No, I need a second person to do it. Want to join me?
Oh,
we lost some people.
Lost it.
Oops.
That's you. Two lines not in the same plane.
No, do one more time, Julie. They didn't get it.
Only one line goes
One
through.
more time, Julie.
Somebody has the idea.
A line and a point.
Mm-hmm.
Intersecting.
Julie, you don't have your microphone on. We can't hear you.
I'm not saying anything.
They intersect one
only one other
Parallel lines don't intersect.
There's only one line that's parallel to another line that goes.
Yes.
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 There's a line. There's a point. There's only
Yeah.
one line.
One line parallel.
Not parallel to that point.
Parallel to the line.
Okay. Here's the bad news.
that's good. Send that this way.
But I have to confess that we're buying from a restaurant that in town. Every Thursday night we do that.
Now, did you guys have a second one that you did, or did you just do the?
We just did the first.
All right. So okay, earlier when you said while I was acting and you said, Julie, what are you cooking? I was like, what are you talking about? I'm doing acting. I'm Julie too. So I was very confused. I was like, what? What are you talking about?
Sorry, I should have spoken.
That's okay.
Should we go back in our groups?
No, we still got.
Oh, you ready for mine?
Did you guys just
ready for the next one?
We got one more at least.
Yeah.
You ready?
Okay. Yeah.
Tabitha's got one for our group too.
You guys can make Todd big.
All right, Todd.
Okay. Triangle.
Click on Todd. Yeah, there you go.
Equilateral triangle. Isosceles triangle. Base angles.
Interior angles of the triangle.
Isosceles triangle are congruent.
Yes.
Julie, say it again.
Base angles of an isosceles triangle are congruent.
Yeah.
Yes. Yeah.
You guys are some smart math teachers.
Okay. Tabitha, you ready? Okay.
Who's next?
Tabitha.
Yes, I had to turn my microphone off. Sorry, I have loud kids running like a herd.
But Todd, you have to guess because we know her thing.
Okay.
But lean back so we can see you.
This was just a side thing.
Vertical angles.
Yeah. Is it vertical angles or congruent?
Yay!
Good job. Yeah. Perfect.
So I guess you can use chopsticks to act that out, right?
Yeah.
I use pencils or chopsticks in class to act that out. If I didn't want to use rulers.
Oh, I have a hole in the middle.
Oh,
There you go.
Perfect.
Nice.
Make it a windmill.
Julie, you gonna do our last one?
360 degrees.
I don't know if I can do the last one. You can try it. You go ahead. You have bigger hand. Because it's hard to I don't know. Okay, who's got it? Car's gonna do it.
Oh.
Okay, Car's gonna do it.
4 minutes. Okay.
So I got this. That.
Can't say it.
Can't see very well. That angle.
The angle of the triangle.
Yep. And the base
angle.
The height.
Isosceles right triangle.
No.
So what kind of triangle is this?
Right triangle.
A right triangle, and you're looking at the opposite leg.
So
that's a hypotenuse.
So
no.
This angle and that
are complementary.
Yeah.
Oh.
We're looking at the legs. We're looking at the acute angles.
We need to have a complementary.
How do you do complementary?
Symbol would be a good complementary.
Yeah, that's right.
There you go.
And Q could have been.
So.
Yeah, we should have done that too.
Yeah.
So that angle make
90.
Yeah.
So they complementary.
I guess it's easier to do it this way. Right angle.
Yes.
There you go.
Oh, there you go.
How do you do complementary? I have no idea how to do complementary.
We did it. We got it. Yeah. You did good job. Well, there you go.
What are you at school? What are you doing with all that? You got everything home with you.
We thought
she's in the remote learning classroom.
I thought I was bad bringing Elmo home with me, but you brought the whole school.
We were talking about how this is good for a lot of kids who are kinesthetic or whatever, to come up with ways of showing things differently.
Yeah.
Yep.
It's good.
I love acting these out. And that's why I was saying to them that having math teachers as your audience makes it so much easier. Knowing that you guys just needed a couple things to get the hint. Where for students that don't know the formulas or the theorems,
Yeah, we were
Thank you
talking
so
about
much.
that. We're talking about know who your audience is, and once we realize it's fellow math teachers, well, they're in the know, so we are. It's easy. But,
Oh yeah.
But some of, I mean, I think this is a good idea, but some of it may not work. I mean, it would be just, it would be in addition to talking, and then it would work well, right? For people for whom this is new, then you would, and I do that. I'm sure you guys too. When I'm talking about triangles, I'm actually visualizing it on the board or with my hands. I find that's useful when you write on the whiteboard and then you walk around and you're kind of almost in people's face walking around doing this. It reinforces it. It's one more way of really seeing that concept.
Yeah, it's just.
Sometimes, oh, go ahead. I'm sorry.
No, you go ahead.
I start out my class with a drawing on the board because I like to draw.
Yeah.
And just to think about, what are we talking about today? So one time I drew, for instance, a bird cage, okay? And the door of the bird cage is open and there's this parrot flying out. And they're just looking at me like, what?
I know what it is.
What is it, Julie?
It's a polygon.
Yeah.
Oh, polygon. I like it.
That's
awesome.
Or I had a guy sunbathing on the beach one time and it was all tangents, So crazy stuff.
That's awesome.
You have to draw an emaciated parrot. Then it would be what? What's that? If you drew an emaciated parrot.
Polygon.
No.
A concave polygon?
A polynomial.
Oh,
Ednomial. I love it.
I enjoyed it, guys. Thank you.
Thanks.
Fun.
Bye.
Bye.
I guess we're going to be somewhere in a minute.
All right.
So again, I want to share the screen, and then here's what we're going to do. I just want to kind of wrap up a little bit regarding how activities such as this can be helpful in the classroom. And then we want to take some time and have all of you share, or some of you share what you've done, because I don't know if you know, but I was spying on some of you as you were working. So there were some great things that I saw. So I'm hoping to have some of you share that out. So let's see, Spencer, can we bring that PowerPoint back up? Or I wonder if I can actually do it this time. Perfect. So let's go on to the next slide. So these are some of the benefits regarding paying attention to students' gestures and having students pay attention to the teacher's gestures. And I use the word gestures, but again, body movement, facial expressions. In the literature, we call this utterances, where it really encompasses everything. But gestures help to direct students, the learner's attention to whatever it is that we want them to focus on, to the big aspects of the statement or of the idea that we're trying to convey. It fosters common ground by connecting familiar objects to unfamiliar objects. It helps to facilitate identifying students' trouble spots and something that we call gesture mismatch. And gesture mismatch is when the student says one thing but gestures something different. And many times what the literature indicates is that the students will tend to gesture something correctly, like I illustrated with Timmy, but what comes out of their mouth does not match the gesture. And this generally shows a readiness to learn and something that we call the zone of proximal development in the literature, that gesture indicates that the student is actually ready to help grasp an idea. Aids with communication, gestures generally accompany verbiage. And as I said, when a student becomes aware of their own gestures, then they can begin to articulate the concepts associated with that gesture. And we've also seen in the research that gesturing can become automatized as the student becomes much more familiar with it. And then as students really have an idea ingrained, they actually tend to let go of the gesture, but it's in that learning process that we see more gesturing. And then this last one is something that connects to the equity panel that we discussed earlier, and I really want to emphasize this. But paying attention to students' gestures is a way to provide a non-linguistic on-ramp to concepts. And this is particularly true for students of an English, who have English language learners. And so where English is their second language. So this is very, very important because the literature again indicates that students can begin to convey a mathematical concept before they can articulate it. And so if we can pay attention and be aware of students' gestures, we can again be equitable and give them an opportunity to convey what it is that they're thinking by simply making them aware of their gestures. And let's see, I think I'm ready for the next slide. So this is a framework that Abramson and Sanchez Garcia use regarding embodied cognition, and I really like this framework. So when I create activities like what I just did or had you guys do, is that the first thing that I need to do is I need to get my students engaged in some problem, some interaction problem, whatever that might be. And as students are engaged in this task, and sometimes it could just be a worksheet. It doesn't have to be something big like what I just did right here, but I did want to do something intentionally that required large gestures. But then what happens is that students find something that they hone in on, some aspect of the concept. And this is something that we call an attentional anchor. And based on what it is that they're focusing on, that's where they begin to develop schemes and to begin to develop their ideas. And these schemes then can be reinforced as we introduce symbolic artifacts or symbolism, mathematical symbolism. And if we know what the students' attentional anchors are, what their scheme is, then we can connect that to the symbolism. And so that's a way in which verbiage, their gestures, and the symbolic or the written aspect of mathematics can come together, especially when the students have opportunities to converse with one another. Let's see, I have, do you know, could you use this in a STAT class? I use this in every class. I just saw that question. I use it with my pre-service elementary teachers. I use it with STAT classes that I've taught. I make my grad students aware of it, but that's part of because of the research that I do. But yeah, anywhere, any class, calculus course, there's literature in all realms of this, in all realms of mathematics. Let's see the next slide. Maybe that was it. Yep, I guess that was it. Okay, so, yep, that was my last slide. I thought I had one more, but I guess not. So I think what I want to do now is, we'll just ask a few questions, but I do want to take time for the groups to share. As we're thinking about this, is to one, think about the benefits of doing this in your own class. And of course, the fact that it's fun and that it can engage everyone, I think, is important, and that's part of being equitable in our teaching practices. I also want you to think about what's challenging, and especially now as we're going into this virtual teaching, I've really had to think deeply about how am I going to really focus on embodied cognition and really convey embodied ideas to my students. And so, for example, I always have this statement of, oh, it looks like you have a question or you have a look. And that's because I am trained, I've been doing this for years, of really paying attention to facial expressions. And when students don't have their camera on, I am really going to be scared to death about that because I want to know what students are thinking. I want to be able to bring them into the conversation by paying attention to their gestures, facial expressions, and body language. And then I want you to think about how you could adopt and adapt this to your own classroom. That's something that I always tell my teachers. It's, you don't have to do it exactly the way I did it, but how could you use it in your own classroom as I see things are coming up, like, for example, in a stats class. So what I want to do now is have some folks showcase what they did, their gesturing, their examples. And I'm hoping that Julie's group might start. Julie Barnes. Let's see, how do we bring them up? Spencer and Brianna, I'm counting on you now.
So if someone wants to come up, if you actually go to the participants, oh yeah, Julie's already coming up. If anybody wants to come up after Julie, just at the participants tab, you can raise your hand and then we're going to kind of call on people one at a time. So I'm going to disappear now.
Yeah,
but my group members were better at this than I was.
Yeah, well, I was wondering, Julie, because I really like, is it possible to bring more than one person up at a time?
Absolutely. So Julie, actually, so if people can either raise their hands, or if you happen to know who was in your group, I can also find them and invite them up. Okay, I see Azucena, and I'm inviting Azucena up. And anyone else? And if you're invited to be a speaker, you can turn on your camera and mic at the bottom of your screen. Oh, perfect. And that would be, okay. Oh, great. Anyone else?
Yeah, so I noticed when I went and spied on the three of you that you actually did one where you all did something different simultaneously.
Yeah.
And I'm hoping that you might showcase that one.
Oh,
okay.
Shoot. Props are, I'm coming back.
I was using strips left over from an earlier session we did this morning.
Okay.
And I was pointing my pen. I started out this way and I said this to show two lines were intersecting. Then I said this angle and this angle. I was doing this.
Yeah, okay, so what I'm going to do is actually have you, the three of you, do exactly what you were doing to showcase the other group. So go ahead, start. Great. And so notice the attentional anchors that the students might actually pay attention to. Is with Julie, that little origami piece going back and forth. And then Madhavi, were you using a piece of paper also?
No, that was Azucena.
Oh, okay, that was you down here. Yeah. But it kind of illustrates the vertical angles and what aspect we're paying attention to. All right. Do we have something that your counterpart will show also? Do you have any suggestions of what you would like them to share? Did you guess your counterparts?
What do you mean? Something that somebody else did from our B group?
Yeah, so I'm wanting the B group then.
Yeah, get them to come up.
Okay, good. So we'll have the B group come up and share one of theirs.
Okay. How do I get out of here?
So who else was with Moira? Is it Moira?
Moira.
Joanne.
Anne and Joanne. Okay.
Hello. Hi.
All right. Do you have something that you want to share? I don't remember seeing exactly what you guys shared, but if you have something.
We had one that had the two of us, so maybe we should try that one.
Okay, great.
Although
this one,
it'll be because we're not on the same level. It'll be is there any way you could switch cameras with Joanne?
Hey, Hortensia, do you want to turn off your camera and microphone just for them to act out their? Yeah.
Oh, perfect. Okay. All right. So. That was ours.
Anybody want to guess?
Well, I guess they all know, right?
Right.
That was great. I love it. And notice that in this case, you worked together as opposed to the other group where they all had something different. And this, by the way, the previous one is that vertical lines are congruent or two lines intersect, the vertical angles are congruent. And this one is given a line and a point not on that line. There's exactly one line that is passes through that point and is parallel to the given line. Very nice. Very nice. Okay, let's see. How about something from group 1A? We'll have you leave, and then maybe group 1A pop up.
Do I have to do something to leave?
I think Spencer might just kick you out.
Moira, you can just turn off your camera and mic at the bottom of your screen, and that will take you off stage.
And then if we can start having people, there we go, from 1A, group 1A. One A or 1B maybe?
Okay, I think Carr is about to come up on stage from 1A. Hello.
Hi. There was also Todd and Julie.
Julie Dunkel.
Kwang Wu.
Okay.
Julie.
Oh,
Kwang
Todd.
Wu.
Okay. Okay, I found Todd. Okay. Oops.
I think it was Q. Her name began with Q. Caffeinated name Q and Wu.
Oh, okay. Okay, let me see. It may be that they had to leave. I'm not seeing.
That's my coworker, Julie Wu.
Yeah.
Oh.
Wiongu. I wonder if she did better.
Yeah, I'm not seeing her, unfortunately. I did make Todd. If you want to turn on your camera and mic, there should be buttons at the bottom of your screen to turn on your camera and mic, and then you could join the stage. He may not be able to right now, I guess.
Bar, do you have something that you did all by yourself?
Yeah, we each did one of the first ones there. So.
Oh, perfect. So go ahead and share yours.
So I did. That's what we did. That's what I did.
Wow. I know I wrote the statements and I have no idea what that one is. We do. Okay, so in a triangle.
That's a triangle, right? And that's,
an angle.
Okay.
There's 1, 4, 8, 0. Oh, 1, 8, 0. In a triangle, the sum of the angles of a triangle add up to 180. Got it. Okay. Sounds good.
We also did the one that the team just demonstrated, the line of point. We did that too. And Todd did
Oh, in an isosceles triangle, the base angles are congruent?
Yes.
Got it. Great. Thank you.
You're welcome.
Thank you. Let's see. How about 1B? Brianna, can you help those folks come up? And Clara, I think if you just turn off your camera and
all right.
Yeah, great. Oh, very good. Hi, Julie. Hi, Tabitha. Anyone else from 1B?
I'm going to get off.
No, very good. Okay.
Team.
Yay. All right, guys, ready to go?
Dilla is in the chat saying he was in our group too.
Yeah.
Barman for the last name.
There we go.
Didn't forget
There we
me.
Yay, team. Okay. 3, 2, 1.
Oh.
All right. I think we're done.
Okay, Sarah got it.
Go, Dee.
You guys got it.
Okay, so do we hang up? What do we do?
I'm laughing because the group, while you guys were working on that, Spencer and Terry were trying to do these, and we were just laughing so hard with exactly that statement. I think that was probably one of the hardest ones. So let's see. So that was one. We did 1A, 1B. We've done the 4s. Have we done group 3s? 3A maybe? Waiting for Brianna. So folks from 3A.
All right. If you're 3A, if you could raise your hand in the participant tab, or else just put in chat and we'll find you. Not seeing anyone yet. We could try for 3B, maybe? What do you think, Hortensia?
3B, go ahead.
Okay, how about 3B?
Be brave.
Okay, I think we have somebody coming up. Oh, Debbie, hello. And Kelly. Hi, Kelly.
Was anyone else in your group?
Yes, Victoria.
Victoria. Todd.
I was only coming on if you guys were coming on.
Okay. Should we do the first one?
The first one that we did?
Yeah. So Kelly, it's you first. Mm-hmm.
Did anybody get it? Okay, somebody's got the parallelogram. No, no.
Yes.
Yes.
Yes, yes.
Got it. Kim's got it. Yes.
That was great. I'm like, what the heck are the sticky notes all about?
Want to do the vertical angles dance really quick?
Okay.
I mean, I can see the answer away, but
Okay. Ready?
Yeah.
Okay. Vertical angle dance. Okay.
Oh, that is great. Here they come. Oh my gosh, that's hilarious. That's hilarious. Thank you.
You're well. That was fun.
Oh, good. Let's see. So we did 4. So how about 5? 5A. Who do we have in the 5A group? Let me get out, and then once you get there.
So Jennifer's microphone didn't work, which was perfect for this. she just could have had to do. Yep. Very good. Shall I do the other one? All right. That's it. Dylan's got it. But
I love that, Kim. Those were both great. That was so fun. I love it. Good job. Let's see, 5B. Do we have 5B folks here? Okay, Sarah, Jack, come on up. Rihanna, I'll let you in.
And Eva. And
Hi, Sarah.
All right.
Do you want to do the first one?
The first one? Sure.
Okay.
Okay. Mhm.
Should we do it again? I got it.
You got it.
Do you want to do the?
Do you stay at the prop for the parallel? Oops, sorry.
Sorry, I was just reading our comment. It's hip to be a square. It distracts me.
That is great. Jack, I loved your little. Oh no, but you have you all have had these giant smiles as you're doing this. So think about what your students will be doing also. That's great. That's great. Let's clap for everybody.
Yay.
Yeah. All right. So I think that we have a few minutes left for any comments or questions that might come up. If you want to put them in the chat, I saw something about Okay, Julie, you have a question? Come on up, ask the question or type it in, however you want to do it. Yes, this is good in conjunction with other modalities. Go ahead, Julie.
Okay, so I'm curious if this also can extend to like something that I do with my students, where I take them out to the soccer field and I set up a goalie and a shooter, and we talk about, what's the best place to stand or defend the shot, and how do you defend 2-on-1, and and you get all these different math concepts in there. Is that similar to an extension of what you're talking about?
It's exactly the same thing. Let me see. Can you turn off your mic? I'm getting some feedback. There, that's helpful. Yeah, I'm a big Steph Curry fan. And if you listen to him, he says he knows whether a shot is going to make it right as the ball is leaving his hands. He knows if it's wrong right as he leaves his hands. The body knows before things actually can happen. And it's really just getting your body and being aware of what your body is doing, because it's connecting. A lot of times they say gesture is a window into the mind. But it's the same idea, having them physically experience something before we talk about and make it mathematize it. So so many times, especially in mathematics, we have to introduce things. We believe we have to introduce things in a concrete manner, and our students aren't ready for that yet. We need to let them experience it first, using their body, gestures, facial expressions, see things, experience things. If you think about the labs like physics, biology, chemistry, they all have labs where they go in and do things and then bring that back to the classroom and talk about it. And this is a way to kind of have a lab within our math classroom. Other questions or comments? Thank you, Julie, for that question.
So, kind of akin to what you just said, we could kind of turn the tables on our students. I often tell my students that I learn so much from them. I hope I'm teaching them a few things, but I learn a lot from my students, and I always do. But you could, when you're teaching something, you could, for reinforcement and to make sure that they get it, is you could ask them to enact something. And another idea I had is what you could do is sometimes we pair students up. So somebody who doesn't quite get it and somebody who's really easy. I tell a lot of my students the best way to learn is to teach. And I encourage all my students to find a younger student, like my 5th graders, look for a 2nd grader and try to teach them things that you aren't expert at, multiplying, addition. But when you teach it, you find that there's lots of things about addition perhaps, or new ways of doing it you hadn't thought about. And so we could use what you're talking about, where the students could be paired up. Maybe somebody who really gets it, think of another way of explaining it. And this actually gets into their muscle memory. So then, I do that with, like I was telling my students just today, I asked them to write things in a math notebook when they get something. And I asked them, why do I ask you to do that? Because there's something about actually writing it that's tied to your brain. And so we were doing x plus y squared, equals x squared plus 2xy plus y squared. And I had them draw it geometrically. And so this is kind of an extension of that, acted out for each other, for me, so I know that you got it, and for yourself.
Yeah, thank you. That's so true. And it brings me back to something else that I talked about at a small roundtable discussion regarding equity. Especially now that we're doing online teaching, I think we really need to rethink how we are assessing our students, and things like this, activities like this, where they have to put together a little skit or whatever. And of course, they can use their words, and we want them to do that. But we can have a different way to assess them. And for me, in embodied cognition, paying attention to students' gestures and body language is a formative assessment of where they are. And so this is a great way to rethink what assessment can look like, especially now during the time of COVID.
And also it's something they won't forget. If they've acted it out, it's something they'll always remember.
It's ingrained in their body. It really is. And then it can become ingrained in their mind. So I think we've got a minute. I just want to say thank you to everybody for coming. And Brianna, thank you for inviting me. I was scared to death to say yes to this, and I'm so grateful that I did. Jack, you have a question before we head out?
Oh yeah, sorry. Yeah, sorry to interrupt you.
No.
So my question is that for this activity, is it fine? I can see that it's good if we wrap up the class after they formally learn the idea. Is it also fine if we do the activity before they engage in the formal concepts?
Oh, for sure. And yes, for sure. And that's what I mean. If you go back to the Abramson and Sanchez Garcia framework, it's that first they engage in an activity, and the mathematizing comes much later after they've developed their attentional anchors. They notice things. So for example, when I want my students to discover that the sum of the angles of a triangle is 180 degrees, I have like 3 different activities that they do. One is to measure the angles and figure out what the sum is. One is to do exactly the activity that was presented, where we tear off the corners and lay them out. And the third is where they actually walk a triangle. So I actually will take rope or painter's tape and lay it out on the floor where I form a triangle, and they walk the sides and then rotate the angle. And what happens is that they recognize that they are facing the opposite direction, so that they know that they have traversed 180 degrees. Oh. And so all 3 of those are using different tactiles. So one is like, okay, just measure, one cut and tape it up, but one is actually stand up and use your entire body. And so I generally try to have more than 2 ways to learn an idea in an embodied fashion, where they believe, oh, this is going to be true all the time. And then we might talk, depending on the level at which we're at, then talk about a formal reason as to why that's true.
Got it. Thank you.
Thank you.
I like your activities.
Thank you. Brianna, you want to come up one more time?
Sure. Hortensia, that was so wonderful. Thank you so much.
Thank you.
Yeah, I laughed so hard. I loved everybody's presentations, and it was like really delightful, in a real way, to see everybody's creativity. So thank you all for putting so much of yourselves into this too.
Yes, thank you.
Yeah.
Yeah, and maybe just one final comment.
Mm-hmm.
What's nice about this is not everybody has to be at the same level. And in fact, it's preferable that not everybody is at the same level, because then the different creativity comes into play. So that's what's really nice about working with groups that are so heterogeneous like this. So thank you again, Brianna, to you, all the AIM staff. Thank you so much. I'm really grateful for this opportunity.
Well, thanks for being here with us today, Hortensia. We really appreciate it a lot.
Thank you.
Yeah. All right. Well, take care.
Bye-bye.
Bye, everybody. See you tomorrow, I hope. Well, maybe not you, Hortensia, but if you want to join us tomorrow. But yeah. But anyway, thanks for being here today.
Thank you.
Okay.